Alright, hi everybody. Welcome. It's our first stream. Let me just double check one more thing. Okay, so today we're gonna do. Oh my camera's not. Let's try. How about now? Okay, so today we're gonna take a look at um the box method. We're taking a look at the box method because, in my personal opinion, this is honestly one of my favorite things to come out of math because um it's something that I found really useful because it transcends age groups. Um, I first actually learned about this after finishing college, and when I was doing a long-term substituting program at a high school, and it was part of what we were supposed to do in our algebra class. Luckily, I had some students that unfortunately were repeating the class, but they were really helpful, and they remembered how to do this, so they showed me how to do this. Um, but then after that, I was also substituting at elementary school and saw that they were doing the same thing, but with multiplying more complicated numbers. So that's why it's one of my favorite things because it is something that you learn very early on, and then you can make that connection way later in your math life. So now this it's something that I really like about math is when we can apply it more than once. So I'm just gonna go through doing some examples of what you would have seen back in elementary school as a reminder of how it works. But then I'm also going to do some examples using our algebra tasks so that you can kind of see how they're connected. So we originally start doing this when we start learning how to multiply 2 and 3 digit numbers together. So we could use it if we wanted to do, let's say, 36 times 74. So we can do this because we apply the box method and we acknowledge that 36 is 30 plus 6 and 74 is 70 plus 4. So when we do the box method, we get to do, we'll do it over here. So because they're 2-digit numbers, we make a 2x2 box. And I usually, when I'm doing box method, whatever's first, I put along the left-hand side. Whatever's second, I put along the top. So I would do 30 and 6 and 70 and 4. And we learn in math that because it's multiplying, the order doesn't matter because multiplication, we've learned is, commutative. That means the order doesn't matter. So whatever thing is first could be second and we'd still get the same result. So with this, when we do this, this breaks it down. And I'm also going to talk about another thing that we learn but sometimes forget. And that's being able to multiply larger numbers with a shortcut, especially when they end in 0. And I actually use this when I multiply bigger numbers together anyways. So 30 times 70, we can simplify that by saying 3 times 7, we know is 21. And then the number of zeros involved gets added on the end. So 30 and 70, there's 2 zeros. So we add 2 zeros. So 30 times 70 is 2,100. 6 times 70, 6 times 7 is 42. And then there's 1 zero involved, so we just add that 0 at the end. 30 times 40, 3 times 4 is 12. And then there's 1 zero involved, so we add a 0 at the end. And 6 times 4 is 24. Now, some people take a look at this and they're like, oh my goodness, you're making math so complicated, this is so different than what we used to do. And actually, it's not. What it does is it just takes what we used to do and it makes it more visual and more organized, which is actually really helpful to a lot of students. Because in the past, so for example, when I was first learning math, and I know that this kind of goes all over the place, but this is part of what I want to do is I want to kind of explain, break things down, make them a little more easy to understand. So when I was learning to do math, we had like long multiplication, so we would do 36 times 74, and once again, we'd do the same thing, 30 times 70. 3 times 7 is 21, and then you do the 2 zeros at the end. And then you go, okay, if we're doing the top, 3 times 4 is 12, and then there's a 0. 6 times 7 is 42. There's a 0. 6 times 4 is 24. Now what you'll notice, oh, sorry, we're a little bit behind me. You'll notice what we just did was the same exact thing that I did in the box method, but the box method just organized it in a more visual manner. So with some students, seeing this long string of numbers here, seeing this long string, oh, where's my laser pointer? Really used to be one. Seeing this long string of numbers can make things a little more complicated. So having it organized, it just changes the way it looks. This actually isn't any different than the long version of multiplication that we've already known or been teaching or were taught and whatnot. So I'm gonna erase this so then what you do with the box method is after we've done the multiplication, put it in boxes, we take those numbers out and we put them and we add them together. So I would do 2,100 plus 1,200. Oops. That's 120, sorry. Plus 420 plus 24. So we can do that. And in this case, lining them up the way that we had in the old way would probably make things a little bit easier for the adding. So I'm actually gonna do that instead. So we had 120, 420, 24. Because then we can do the long way of adding, so 4. Then we have 2 plus 2 plus 2 is 6. 1 plus 1 plus 4 is 6. And then 2. And then if we wanted to check with a calculator, $74 times 36 is 2,664. And that's what we got. And we got to do that a little bit easier because, well, it's a lot easier if you just use a calculator. And then you also have when I was younger, I was thinking about, I always never have a calculator with you. But guess what? Now we do. We have our phones with us and they always have a calculator. But having this ability kind of makes it so that you can use the skills you learn here, because learning how to do the box method, by having that visual organization, it does make it easier for you to do things in your head. So doing things in your head can sometimes be faster than getting out your phone and typing it in if you get good at it. Also being able to do things in your head just kind of can give you more confidence too, because knowing that you can do it in your head will make you feel a little smarter and more skilled. So let's do another one. Let's do a 3-digit one. Let me move this over. We have space. We'll do this one in purple so we can just keep things separated. We'll do a 2-digit times 3-digit. So we'll do 30. No, I just did 30. Let's do 50. Oh, really wanted to do a 3 apparently. We'll make it 53 then. 53 times 289. So with this one, remember to do box method, you need to break it down into each of its digits. So 53 is 50 plus 3. 289, we need to break it down into 200 plus 80 plus 9. And so with this one, it is going to matter which one we put where in terms of the way we draw our box. So typically I draw, like I said, first number I usually put it all along the left hand side. So I'm going to make it 2 tall and 3 across. So we have 50 and 3, and then 289. So with this, we can do a lot bigger numbers because we can break it down and make it easier. And another reason, just to kind of sidetrack a little bit, another reason I really found that I like the box method is it's very similar to another version of multiplication that I learned about when I was in school, and it was called the lattice method, and I used that for a really, really long time. I even used it when I got the higher level maths, and I actually once had a teacher say That's a really elementary way of multiplying. You used to not doing it that way. Which confused me because I was like, if it works for me and I still get the answer, why does it matter? And it is a proven way of being able to multiply. Um, so I didn't see the problem, and I honestly, as a teacher, I still don't see the problem. I don't care how you learn to multiply, add, subtract, do algebra, graph, do geometry. If it's a proven method, unless I'm giving you a question that specifically asks you to do it a certain way, do whatever works for you. Um, Honestly, math for a lot of people is hard enough as it is. If you have a way that makes sense to you, you should stick with it. So let's go back on track to this. And sorry. So 50 times 200. Well, we know 5 times 2 is 10. So that first zero comes from the 10. And then there's 2 more zeros involved. So it'd be 10,000. 50 times 80. 5 times 8 is... That's what's happening. 5 times 8 is 35. And then there's 2 zeros. 50 times 9. 5 times 9 is 45. And then there's 1 zero. 3 times 200. 3 times 2 is 6. And then there's 2 zeros. 3 times 8 is 24. Now the other thing that this is nice with, and this is why I like the lattice method that I referenced earlier, is it made it into essentially a whole bunch of one-digit multiplications, which is a whole lot easier than trying to do bigger numbers. Which is what's nice about this and why they teach this to you guys when you're younger. So we have 1 0, and then 3 times 9 is 27. So then after we have that, we do all these. We just take these individual numbers and we add them together, which was the original multiplication method. You break it down. But I think doing it this way, it just kind of makes it easier to see, because if we had, now we'll reference that earlier one, we had 53 times 289, and we had it this way, you don't see the zeros that are involved here to know to put them at the end. It's a little harder to notice. They teach you the other way and they expect you to kind of remember it, but if that's hard for people to remember, then having this box method does make that part more noticeable. I don't need this one anymore. Alright, so let's finish this one up. And then I'll grab my calculator and check ourselves again. So we had 10,000. And I'm gonna do it vertically again, because it's a lot easier to add together. Keep it down. It's missing my mouth tracking. And then we have 3,500. And 450. 600. And 240. And 27. So with this, we can add them all up, and we're going to have to do some of the carrying. We didn't have to carry anything in the previous one. So first one, we have just the 7. But then we have 5 plus 4 is 9. Plus 2 is 11. So we have 1. We'll carry 1 here. 1 plus 5 is 6. Plus 4 is 10. Plus 6 is 16. And then plus 2 is 18, so we have an 8. And we carry another 1. 1 plus 3 is 4. And then 1. So if I do this with my calculator, we should have, we said 53 times 289. What did I miss? I multiplied the 5 and 80 wrong. That makes a big difference. 5 times 8 is 40, not 35. See, even we can make mistakes sometimes. 40 and then 2 zeros. So that this should be 4,000. Okay, so that changes this one and this one. So we'll go back here. 1 plus 4 is 5, plus 6 is 11, plus 2 is 13, so that should be a 3. And we still carry the 1, 1 plus 4 is 5, and then 1. So on my calculator, this is what tipped me off that I did something wrong, because what I got here didn't match what the calculator said. So it would be 15,317. So let's take a look. Oops. Where does it keep doing? Let's take a look at how we can do this in algebra. So we just did it in basic numbers, and now we're gonna do it in algebra. So I did a 2 by 2, so 2 digit by 2 digit, then a 2 by 3. So I'll do the same thing with an algebra problem. So I'll do a 2 by 2, and then a 2 by 3. Like this part needs to still be. Okay. Alright, so let's go the blue now. Alright, so in algebra when we have this, it's already usually broken up into your addition part, or sometimes subtraction. So to keep it simple this time around, just because this is what we're talking about, we'll just keep it all addition. So we broke down in the first example, 36 into 30 plus 6. So when we're given an algebra question, we're given, let's do somewhat similar still, and we'll do 3x plus 6. So instead of 30 plus 6, it's 3x plus 6. And then it's multiplied by, and then we'll do 7x plus 4. So we're keeping it similar to what we already did to kind of help with that. And I did draw it a little too big, so I'm not going to have the space I want. So I'll just have to move the screen. And then to set it up, we do the same thing. So we create our box. So we're going to make a 2 by 2 box. And we have 3x. And when I do this with algebra, I like to keep the symbol, so plus 6. Especially when we have subtraction, even though I said I'm not going to do any subtraction. But I like to keep the symbol there because it helps remind us if we have a positive or a negative number. So then we have 7x plus 4. Hope even if I have people watching, that's what I get for being new. I haven't, seen my chat if I have a chat. Maybe I need to activate it in my. Well, we'll learn from our mistakes and address this for next week. So, with this, we have it set up, and like I said, I did it similar, so we have 3x times 7x. So 3 times 7 is 21. And then for this, we have x times x is x squared. So this is a skill that when you get into algebra, you'll learn how to do this part. 3x times 4, 3 times 4 is 12. And then with this one, there's only one x, so it comes a lot for the left. 6 times 7 is 42. And then there's one x. And then 6 times 4 is 24. So you'll notice this one, a lot of the numbers are similar to what we had before. But with this one, instead, we have a bunch of different variables. So this one, it is okay to do a string of addition instead of the vertical addition, like I did with the numbers. So we would then bring out what we have. So we'd have 21x squared plus 12x plus 42x plus 24. So now we have that, and we can do our combined like terms. So we're going to take and we're looking for like terms. So I actually talked a little bit about like terms in a future video. So that'll be uploaded later. But x squared and x are different. In order to be like terms, they have to have the same exponent. So 21x squared is the only x squared term, so that would be fine. But then we have 12x and 42x. Those both have an x, so we can add them. 12 plus 42 would be 54x. And then the 24 is the only constant, the only plain number, so that one let's stay as is. And then that's all combined, so that's good. So that would be what we have here. And like I said, I like the dots method because it organizes things and makes them a little bit easier to manage. And also because, as I already showed, it connects to something that you learned in elementary school, which is box method by multiplying just multi-digit numbers. So, hopefully, this makes it make a little more sense. I am going to do another one. My plan is to do 3:30 to 4:30. I know that I start a little bit late. But we'll go from there. So, we'll do. We'll make this one red, so I'll just cycle through the three colors that I have. So like I said, I'm gonna do a 2-digit and a 2x3. So I'll do similar to how I did before. So we have 5x plus 3, similar to that 53. And then we'll do 2x squared plus 8x plus 9. I did 289. And then that's gonna be behind me. So we'll scooch this over so that we have enough room for everything. So with this, we're gonna do another a 2x3 box. And we would have 5x plus 3. And then in the top we have 2x squared plus 8x plus 9. So 5 times 2 is 10. And then x times x squared, remember it's x the first. And if you learn about variable multiplication, we add the exponents. So it would be x cubed. And we're going to multiply 5 times 8 correctly this time. 5 times 8 is 40. And then x times x is x squared. 5 times 9 is 45. And then there's only the 1x, so we get 45x. And then we have 3. 3 times 2 is 6. And then 3 is constant, so there's no additional x multiplication, so it's going to be 6x squared. 3 times 8 is 24. And then x, and then 3 times 9 is 27. So now that we have that, I didn't do this in the first one, but I'm going to do it this time. So another thing with this, that I like, that students tend to struggle with this sometimes, is cleaning it up before bringing it out of the box. I usually teach this by just saying, just bring all the numbers out of the box every. Is it coming back? There we go. Alright. I don't know why my headset keeps turning off even though I'm using it. So I usually teach it by just like bring all the numbers out of the box and then combine them then. That way you don't have to worry about messing anything up or getting lost, anything like that. It makes things a lot easier. But there is a way for people that can understand it and grasp it to clean it up beforehand, and that is to add the diagonals. So you'll notice when we did this, and it actually was true for the other one as well, we used a highlighter. Hopefully this is a good color. No, let's change it to the blue should show. Well, actually green, really greener contrast. You'll notice if we do diagonals, and it pretty much is always diagonal, to the right. So 6x squared, 40x squared, if they're diagonals and they're all combined, they're like terms. And I'll just do a different one. And then the 24x and the 45x. So they're diagonals to the right. You can combine them before bringing them out, which would make it basically a one and done thing. So the 10x cubed is the only x cubed if you look at all the boxes. So we'll bring out the 10x cubed. I'll do it below here. 6x squared and 40x squared. We can add those together because they're like terms and they are like diagonals, and typically that's what we get. We get like diagonals. That gives us 46x squared. And then the 24 and the 45. Gives 46. 4 plus 5 is 9. Gives us 69x. And then the 27 is the only constant. So you'll see we can combine them before bringing them out, which means we don't have to do the combined like terms that way. But as I said earlier, when I was starting it, sometimes students get a little hung up on figuring out which diagonal it is, but it is pretty much typically up and to the right. So we went up and to the right, based on how the multiplication happens. Now, if your original polynomials aren't already in order, so you'll notice I wrote it in descending order because that's the standard way to write them. So if I had instead started with 8x plus 9 plus 2x squared, then that might not work. But a good way of if you're going to do the box method is if you can fix it so that it's in descending order before you do it, because it'll make it a little bit easier to work on. So I'm gonna pause on some learning stuff, and I'm just going to, I know we're already live, I'm gonna fiddle around with my things to see if I can figure out about what's going on with chat. If we have a chat. Settings, output, nope. So yeah, so this is our first stream. I want to try and do Wednesdays from 3:30 to 4:30. Streaming, non-streaming services reputation. Maybe I have to do it at YouTube. Let's check that out. I have that. Well, chat is disabled for this live stream. There it is. Okay. So, maybe it's because it's my first one. So, hopefully, I know this is my first stream, so there's probably not many people here. If there's one person, then that's me, because I was checking it out. That's okay. This is how we start. So, let's take a look. You know what? We're doing things with box method, and I mentioned it earlier. Why don't we use the last bit of time to talk about that last method that I mentioned earlier? So I don't think they teach this in schools anymore, but in all honesty, I think it makes it really easy to do some multiplication. So if you watch this and it makes sense and you like it and you want to use it, then by all means, just for sure figure out what happened to my pen. There it is. Alright, so let's see, we'll write it in English. I'm a math teacher for a reason. That's because I can't spell. Well, but I did know how to spell. So Lila's method of multiplication. So I used this a lot when I was getting used to not getting used to they taught me this at some point in like middle school or something, and it stuck and made sense to me and I latched onto it. Um so I still use it when I don't have my calculator with me. Uh it's fun to be honest. Or if I just don't feel like getting it out. Um And basically, the idea for the last method of multiplication is you use box again, and that's why I'm bringing this up with this. And you know what? Let's keep our examples of what we were using. I was doing, it goes this way. So instead of being left hand side and top, it's top and right hand side. So what you do is you figure out what numbers you're using. So let's use the 36 and the 74 like we did before. And what you do is you draw these diagonals because whenever you multiply numbers together, especially single digit numbers, because the one reason that I like this is I was really good at my single digit multiplications, facts. Um, I think I still am. I pretty much have most of them down. Um, is it turned everything that I had to do into single digit multiplications just times. So what you do here is we divided these boxes into two sections. The top left of each box use the tens place, and then the bottom right of the box would be the ones place. So if we did 3 times 7, that gives us 21. So we will put the 2 in the tens place here, and the 1 here. 6 times 7 is 42. So you put the 4 in the top left, and the 2 in the bottom right. 3 times 4 is 12. And 6 times 4 is 24. And then what this does is it actually sorts all our things here so that we can do that like follow the addition on in this spot instead. So each little diagonal breaks down what sections we add together. So 4 plus nothing is 4, so we have the 4. 2 plus 2 plus 2 is 6. 4 plus 1 plus 1 is 6. And then 2. And if you remember when we did that earlier one, we did get 2,666 is our answer. And then if you have to carry anything, you just put it, and actually we have to carry the other one, so I can show you that. We'll do that with the 3-digit one. And then so with the lattice method, again, you do it according to the numbers you're using. And I'm actually gonna change up the order because it just is gonna be easier to write. So with our other one, we did 53 and 289. Oh, and it's behind me again. That should be good.